I need to rescue this damsel from this burning house. Don't worry, miss. I'll save you. Ow! This fire is hot.
Here, take this.
Are you sure this will work?
Of course. Come with me to my lab. I'll show you. And here we are.
So what's this jacket made out of? How will it protect me?
It's made primarily of aramid fibers, specifically Nomex and Kevlar.
Nomex and Kevlar? How will those help?
Both Kevlar and Nomex have very high tensile strengths and are very resistant to fire. Since firefighter uniforms are 93% Nomex and 5% Kevlar, firefighter uniforms tend to be very strong and very fire resistant.
So how do these fibers work? Why are they so strong and fire resistant?
For that, we'll need to look at the chemistry behind the fibers.
Kevlar is produced by combining these two substituted benzene rings. Because the functional groups are in a para configuration, in other words, in opposite sides of the benzene ring, Kevlar forms a trans-connected, perfectly straight polymer chain. These polymer chains can be 1 to 5 million units long. The resulting polymer is made up of strong, stable aryl rings and covalent bonds. These bonds are very difficult to break because of their stability. Also, these polymer chains form hydrogen bonds, connecting the chains to each other.
Because these chains are so long, London dispersion forces help hold the chains together too. The result is a fiber with a very high tensile strength. It's used in firefighter gear to prevent thermal shrinkage.
That's cool, but what is the Nomex for?
The Nomex is very similar to the Kevlar actually. There's just one small difference.
The functional groups on the reagents are slightly different. They're in a meta configuration. As a result, when Nomex polymerizes, the polymer chain has kinks and folds in it. The resulting polymer chain still has the same strong covalent and hydrogen bonds of Kevlar, so it's still very resistant to heat.
But it isn't perfectly straight, so it doesn't form the perfect rods that Kevlar does.
Sure, but how does that make Nomex any different from Kevlar?
The kinks and folds in the Nomex polymer make it more flexible than Kevlar, making it better for clothing. The small amount of Kevlar in this uniform helps prevent thermal shrinkage, making sure that the uniform doesn't tear itself apart due to extreme heat.
That's great, but I've gotta go save that damsel.
No, wait, this part's really important. See this graph? It shows you the internal temperature of a firefighter suit at different distances from your average house fire. 15, 10, 5, 2, and 1 centimeter. You can see how dramatically temperature increases with distance, so be sure not to get too close to the house fire.
So how close is too close?
You probably don't want to get any closer than 5 centimeters from the fire. As you can see here, the internal temperature of the suit at 5 centimeters from the fire gets up to a toasty 40 C. At 2 and 1 centimeters, you get between 50 and 70 C. That's really hot. So try not to stay within 5 centimeters of the fire for prolonged periods of time.
Then how helpful is this suit? I can't even get into the fire.
The suit will still do an excellent job of protecting you from the fire. Take a look at this graph. See this red line? It shows you the external temperature of the suit about 1 centimeter from your average house fire. This temperature is really hot. It's about 400 C. The temperature between the layers of the suit is about 120 to 170 C, which is still pretty high. The temperature on the inside of the suit is 70 C, which is high, but it's a lot lower than 400. And the suit wasn't even scorched by this test. So this suit will definitely protect you from fires.
Gotcha. It looks doable, but I'll have to be careful.
Excellent. I'll take you back right away. All right, now you have what it takes to save the day. Go on, go save the damsel.
No.